The next type of integrals we're going to learn is trig product integrals, and this is going to be part 1. We're going to learn the product of sines. Things of the form sine to a power times cosine to a power dx. Identities we'll need: sine squared plus cosine squared equals 1, sine squared theta equals 1 minus cosine 2 theta over 2, and cosine squared theta equals 1 plus cosine 2 theta over 2. We've used those before. So our first case that we're going to look at is m is odd. So while I'm doing this, I'll just give you an example and I'll describe the process as we're going through. We have sine to the 5th of x over 2 dx. The first thing we're going to do is separate a sine x dx. So we're going to take this thing and we'll write sine to the 4th of x over 2 times sine of x over 2 dx. We need to take out a sine x dx, and that's what we have. We don't worry about, as long as we have other constants or whatever that's in there, we have a sine dx. Then what we're going to do is substitute the remaining sine squared x with 1 minus cosine squared x. And so since m is odd, the power of sine is odd, when we take out one sine, we'll have an even power left. So this is sine squared squared, and if sine squared is 1 minus cosine squared, this will be 1 minus cosine squared of x over 2 quantity squared, and then times sine of x over 2 dx. Now we'll say integrate by substitution. So what's our substitution when we're looking at this? The reason why we pulled out this sine dx is because that is the derivative of cosine x. So our substitution will be let u equal cosine x, and then we'll find du is whatever the case. In this one, it'd be negative sine x dx. But whatever that is when you have a coefficient of there like we're going to have in this problem. So we'll say let u equal cosine of x over 2, then du will be negative, and then when we take that derivative using the chain rule of the inside, we get a half, negative 1/2 sine of x over 2 dx. So in other words, this sine of x over 2, which is what we have there, will end up giving us our negative 2. So when we substitute this in, we'll have 1 minus cosine is u, so that will be cosine squared quantity squared times negative 2 du. We can take the negative 2 out, and since we don't have a u outside here, we're going to have to square this out. We'll get 1 minus 2u squared plus u to the 4th du. And that's fairly straightforward. To integrate, we'll have negative 2. The antiderivative 1 is u. Antiderivative of negative 2u squared would be negative 2/3 u cubed plus 1/5 u to the 5. And then we have our plus c. We weren't asked to integrate in with respect to u. We had this sine thing to begin with. So now let's make our substitution back in. And we can just go ahead and multiply that 2 out at the same time. So we'll have negative 2 cosine of x over 2 plus 4/3 cosine cubed of x over 2 minus 2/5 cosine to the 5th of x over 2 plus c. Now let's look at the next case. Case 2, if n is odd, based on looking at case 1, I think you could probably figure out what case 2 is going to do. If n is odd, that means what we can do here is separate a cosine of x dx. Because again, we're going to be looking to do a substitution here. So we'll have, let's take that out first. We'll have sine squared x times cosine squared x times cosine x dx. Just like in the first one, we're going to substitute the remaining cosine squareds. Again, since this was even, or since it was odd and we took out 1, we'll now have an even number left. So we're going to substitute that with 1 minus sine squared x. So let's do that. Here we'll have sine squared x, we're not touching that one, times 1 minus sine squared x times cosine x dx. And we'll go to third step. And what we need to do is integrate, and we're going to do a substitution by substituting let u equal sine x, and then compute the du, whatever that one is. In this case, it'd be cosine x dx. So let's do that. Let u equal sine x. Du will be cosine x dx. So we'll get the integral of u squared times 1 minus u squared times du. Multiply that out. We'll get u squared minus u to the 4th times du. So we'll have 1/3 u cubed minus 1/5 u to the 5th plus c. And now substitute back in. U is sine x. So we'll have sine cubed x over 3 minus sine to the 5th x over 5 plus c. Notice we have this has a sine and a cosine, and our answer only has sine in it. On the previous problem, we had sine is our integrand, and yet we had 3 different terms with all different powers for the cosine. You cannot just look at it and know, oh, this is how many terms we're going to have. So they're a little more complicated than what we had.